Okay, this is going to be part one of the video series on trigonometric integrals, and they come in two types. One of them involves sine and cosine. The other one involves the tangent and the secant. So in this video, we'll look at the one that involves the sine and the cosine. Now, they usually say up in this form right here, it'll be the integral of the sine raised to a certain power times the cosine raised to a certain power. And if you look in most math textbooks, they will give you some guidelines about how to approach solving these problems, and I've put them in this form right here. So we've got three possibilities. Now in this video, what we're going to do is this, is rather than actually solving the problems all the way out to completion, we're just going to look at how to set them up, because sometimes the setup's actually the hardest part of the problem. So what the rules say is this, and again, when you read them in words, they're kind of hard to understand. When you actually see some examples, you'll see that they're not that bad. Let's kind of run through this. So the first one says this: if you've got a problem in which the power of the sine is odd, so if the sine is odd, then the idea is to save one sine factor and convert the remaining factors to cosine. Now again, we'll do some examples here in a second and show what this looks like. Then second possibility, maybe the cosine is to an odd factor. If that's the case, you'll save one cosine factor and convert the remaining factors to sine. And then the third possibility is maybe both the sine and the cosine are to even powers. If that's the case, then you'll convert them using the half angle identities that hopefully you'll remember from your trig days. Now again, all this stuff probably doesn't make much sense right now, but we'll run through some examples and show how they all work. So let's do this. Now before we get around to the examples, you need one more thing. In addition to the rules, you need to remember a couple of identities and derivatives. So first of all, an identity that's going to pop up here is this. In these problems, you're going to need to change the sine into a cosine, and the only way to do that is the sine squared is equal to 1 minus the cosine squared. And then also you might remember cosine squared is equal to 1 minus sine squared, and you will use these definitely in the problems. Now the problems also involve derivatives, so just a reminder, the derivative of the sine is the cosine, and the derivative of the cosine is the negative of the sine. So just kind of keep these problems in mind as we go through here. Okay, now let's go back and we'll kind of take a look at each one of these three possibilities in order. Now the first one says this: if you've got a problem in which the power to the sine is odd, save one factor, sine factor, and convert the remaining. So let's just concentrate on this first type and look and see what some of the problems might look like. Okay, we'll actually do two of these, and we're going to set them up now, not necessarily work them all the way out. Again, first of all is recognizing what type of problem you've got. So if you look at this problem, the first thing you'll see is that the sine is odd. So if you come up here, the sine is to an odd power. So since the sine is to an odd power, what the rule says is save one sine factor and convert the remainings to cosine. Now what does that mean? Well, let's take a quick look here. It actually is going to wind up looking like this. You'll have the integral of, now what you've got is a cubed here. So you've got three sines. So the idea is to take one of these sines and move it over here and save it. So when you do that, if you had three sines and you take one of them away, now you've got a sine squared of x. Now we'll go ahead and leave this cosine squared right here. And then you took one of the sines, move it over to this side, that's going to give you a sine of x dx. Now, the reason you're doing this is kind of an odd thing to start with. Eventually you're going to get around to use substitution. I think I'll go ahead and put a little box around this right now. This is the part that you're going to try to remove on use substitution. You wind up needing one sine all by itself. So now we'll work with what's left over. So your first step, you took one of the sines from here and just moved it over to the side and saved it here. So now the next thing says this: you've got it saved, so convert the remaining factors to cosine. So here are the remaining factors, but you've got to change all of them to cosine. So you need to change this sine squared into a cosine squared. Now how do you do that? Well, it's going to be the integral. And again, just remember your identities. To change a sine squared into a cosine squared, you change it into 1 minus cosine squared. So this is going to change into 1 minus the cosine squared of x. And then you still got the cosine squared, and then you've got the sine of x dx right here. Now the reason you're doing all this is you want to put this entire part right here in terms of cosine so that you can use substitution. Okay, the next thing you got to do is to distribute on this problem. You can go ahead, since this is to the first power, you can go ahead and distribute this cosine. So this times this, and this times this. So that's going to get you to the integral. Now 1 times cosine gives you cosine squared, and then you've got a minus. Now add the exponents. Squared and squared would give you cosine to the 4th of x. And let's go ahead and put that in parentheses. And then you still got the sine of x dx. Now what this does, this gets you through what I call the setup part of the problem. At this point, to solve this thing now, you're actually going to let u be equal to the cosine of x, and off you go, solve the rest of the problem. So, but the tricky part is just changing the original problem into this form using this rule right here. Now, that was the sine squared, or sine cubed times the cosine squared. Let's try one more because they get a little trickier as you go along. In this problem, you didn't have to FOIL this inside part, but watch what happens on this one. It gets a little trickier on this. Now, the first step is still the same thing. And by the way, this comes up a couple times too. Sometimes both the sine and the cosine are to an odd power. So the question is, which one do you pick? And the answer is you can pick either one you want to. It'll work just fine. Now, normally I pick the one with the highest power to move over, but it'll work just as well if you were to work with the odd power of the cosine. But in this case, we're going to say we've got a sine to an odd power, so we'll use this rule right here. So what the first thing does is you've got 5 sines, take one of them and move it over here to the right. So this would become the integral. Now I'll have sine to the 4th of x. So I'm going to take one of these sines and move it over just like before and put it right here. So then I've got a cosine cubed of x, and now that one extra sine is set over here, dx. Now again, what I'm really shooting for here is to use u substitution, and this is what I will use to complete the u substitution. Okay, now the next thing says convert the remaining factors to sine. So just like you did over here, you took this sine squared and changed it into a cosine. Well, you want to do the same thing here, but you've got to do a little bit differently. So since it's a sine to the 4th power, you'll have to rewrite it like this. Rewrite it as the sine squared of x squared. Then you've got the cosine cubed. Then you've got the sine of x. Now the reason you're doing that is because you've got an identity for the sine squared, but you don't have one for the sine to the 4th. So here you didn't have to worry about that because the whole thing was to the 1st power. But here, since it's to the 4th power, you have to make it squared squared. Now on the inside, this sine squared of x you can change into a cosine. So again, the sine squared is 1 minus the cosine squared. But it's still squared. Then you've got a cosine cubed of x. Then you've got the sine of x. Now the reason this one's going to take a little bit more work is right here. On this one, you had the cosine of x to, or 1 minus the cosine of x squared to the 1st power, so you didn't have to FOIL it. You just changed it into that. But here what you've got is 1 minus the cosine squared, the quantity squared. So you have to think of it as 1 minus cosine squared times 1 minus cosine squared. And I think I'll put it in red here. In this case, you're going to have to FOIL this thing to get it in the final form. So let's see what that looks like. So that's, again, just think of 1 minus cosine squared times 1 minus cosine squared. And what that would give you, the first ones would give you this, then you'll have minus. Now the two inside parts would be 2 times the cosine squared. And then finally, the last part, you've got plus. Cosine times cosine would be cosine to the 4th of x. All of this times the cosine cubed of x. And then finally, you've got a sine of x here, then dx. Now again, you're going through all this to change everything except for this last part. You want to change it all into cosines. Now, next step, take this cosine cube and distribute it to all 3 parts here. So this will become the integral of, times first one will be a cosine cubed. Then you've got minus 2. Now again, add the exponents. Cosine squared times cosine cubed would give you cosine to the 5th. And then finally add the exponents here, plus this would be cosine to the 7th of x. Put parentheses around all this. Then you've still got the sine of x dx. Now you're ready to actually solve it using u substitution. So again, if you let u be equal to the cosine of x, then you can use u substitution and complete it. So all of these steps are just what I would call the setup, trying to get through these words right here. So if you're lucky, you just have a 1 minus cosine squared to the first power. If you're not lucky, you've got a 1 minus cosine squared raised to some other power, and you've got to FOIL it and maybe cube it. It just depends on the problem. So there's a couple show you how to set up the problems if the sign is odd. Now let's take a look and see what to do if the cosine cosine's odd. Okay, now again, what we're looking at here, let's go back to the rules again. Now we're going to look at this second step. Suppose the power of the cosine is odd. This time, save a cosine, change the remainder to sine. So it's sort of like the thing we've got through doing, just a little bit different. You're working with cosine this time. Okay, now again, looking at the problem, what you've got is the cosine is to an odd power, the sine is to an even power. So this time you'll use this rule. Now what it says to do is exactly like you did before. Rather than saving a sine, this time you're going to save a cosine. So take one of the cosines and move it over here. So again, this is going to be, you had 3 of them, so now you've got 2 of them left. Then you've got the sine to the 4th, and this sine could be to any power. And take this one cosine and put it over here. So you've got a cosine of x dx. Now again, just like in those previous problems, this little group right here is going to be what you're going to get rid of when you do the u substitution. So now your task is to change all this remaining stuff into sine, factors of sine. So again, using an identity, just a reminder, the cosine squared is 1 minus the sine squared. So what this will turn into would be the integral of 1 minus the sine squared times the sine to the 4th, and then you've still got this cosine of x over here. And again, just like those previous problems, go ahead and distribute this sine to the 4th. So that's going to give you the integral of the sine to the 4th of x minus, now here, add the exponents. That'll be the sine to the 6th of x, put parentheses around it. Then you've still got the cosine of x dx. Now at this point, you're finally ready for u substitution. Okay, now at this point, you can let u be equal to the sine of x, so that will be your u substitution. And if you do u substitution, then everything will work out fine. So that's how you set this problem up. Okay, now this problem again did not require foiling. Let's take a look at one more example where you're required to foil it. Now again, I'm going to look at this. You've got cosine to an odd power. So since the cosine is to an odd power, I'll take one of the cosine factors and move them over here. Now once again, both these are to an odd power, so really you could work with any one if you wanted to. Personally, I prefer to work with the highest powered one. So let's go ahead and try this one. So it's going to be the integral of, now I'm going to have the cosine to the 4th of x. I've still got the sine cubed of x, and I took one of those cosines and moved it over here. So I've got the cosine of x dx. Now, just like in that last problem, the reason for doing this is that you're going to eliminate this as part of your u substitution. You need to have one cosine all by itself over here. But on this case, you've got a couple of extra steps to do now. Now here you had a cosine squared. You could change a cosine squared into a 1 minus sine squared. But here you've got a cosine to the 4th, so again you have to rewrite it like this. Write it as the cosine squared of x quantity squared. Now why do you need to do that? Because you've got an identity for the cosine squared, but you don't have an identity for the cosine to the 4th. Then you still got the sine cubed, and you got the cosine of x. So again, using your identity, and just a reminder, the cosine squared is 1 minus the sine squared. So you can change this into the integral of, and change that cosine squared into 1 minus the sine squared. Then the whole thing is squared. Then you've still got a sine cubed of x times a cosine of x dx. Okay, next thing to do, you've got to FOIL this, because you think of it as 1 minus the sine squared times 1 minus the sine squared. So you'll have to FOIL this part right here. So that's going to get you to the integral of, and we'll put it in parentheses, 1 minus 2 times the sine squared. And then sine squared times sine squared would be plus the sine to the 4th of x. And all this times the sine cubed times the cosine. Again, next step, go ahead and distribute this sine cubed. So that's going to get you to the integral of the sine cubed of x minus 2. Now add the exponents here. You've got 2 and 3 would be sine to the 5th of x plus the sine, and again, add the exponents, 4 plus 3, this would be the sine to the 7th of x. Now all of this is going to be in parentheses. Then you still got the cosine of x dx. And really you're through now with the setup part of this problem. All you have to do here is let u be equal to the sine of x, and you can do a u substitution then and solve this problem. So again, if you're not lucky, you'll have to do the FOILing. If you are lucky, then you can get by without the FOILing. So there's a problem. I'm showing the second step, what to do if the power of the cosine is odd. Now last thing, what happens if the power of both of these are even? So let's take a look at that possibility. Okay, third thing says this: if both the powers of the sine and the cosine are even, so if this is even and this is even, then you switch to a different technique and you're going to do your conversion, but you're going to use the half angle identities. And just a reminder from your trig days, the sine squared of a single x is equal to 1/2 times 1 minus the cosine of 2x. And the cosine squared would be the same formula except it's a plus. But again, if it's the cosine squared of x, you can change it into the single cosine of 2x. So those are the half angle identities. So with that in mind, let's try now a third sample and see what that's going to look like. Okay, so just here's what the formula says. If the powers of the sine and the cosine are both even, then convert them using the half angle identity. So I'll put them here again. Let's look at 3 samples just to sort of show how to go about setting this thing up. Okay, now what happens is that the power here is even, so you've got an even power, so you'll use this rule. Now it's a cosine to an even power, so you'll change it into this form right here. So what we'll do is change this into the integral of, now it'll become 1/2 of 1 plus the cosine of 2x dx. Now in this case, you can use u substitution. You'll be able to let u be equal to 2x and off you go. So this one is really just a matter of changing it into the formula itself. Now also a reminder, suppose you had the sine squared, but rather than an x, you had a 3x here. Well, as far as the formula goes, it's sine squared, so it's going to be 1/2 of this, but let's go ahead and try that. So this is going to become the integral of, and the sine squared will turn into 1/2 of, now it'll be 1 minus the cosine. Here's where you got to be a little bit careful of. Now what goes in here? Well again, if this is x, then this is 2x. But if this over here was 3x, then this is going to be twice that, or 6x. So if you start with a 3x here, when you double it, you'll end up with a 6x right here. So watch out for how you set these things up. So there's that one. Again, we're not going to solve these, we're just going to set them up. Now finally, in the last one, suppose you had both of them in here. So what you've got is a sine to an even power and a cosine to an even power. We'll really just use the formula twice. First of all, change the sine into this. So you can think of this as being 1/2 of 1 minus the cosine of 2x. And then this is times, now use this formula. This would be 1/2 of 1 plus the cosine of 2x dx, and then you'll just combine everything and off you go. So there's an example of just kind of how to set them up using these different rules. So let's go back and take a quick look at the whole thing now. The idea is if the power of the sine is odd, do it using step 1. If the power of the cosine is odd, you do it using step 2. And by the way, if both powers are odd, you can use either step you want to. Then if the powers of the sine and cosine are even, do this. Now we've got one more problem we're going to solve in here, and it's what I'm going to call a special case here. Right now you might be under the impression anytime you see something in the form the sine raised to a power and the cosine, both in the same thing, you have to use this long expression, factor something out, change it, use some identities, and so on. But that's not necessarily true, so let's look at what I'm going to call a special case. Okay, now here's what the special case is. I think I'll put it in red here. Here you have sine and cosine. All of these have a sine and cosine in them, but the special case is this. If you happen to get really lucky, one of these will always be to the first power. So cosine of the first power, cosine of the first power, sine of the first power, and sine of the first power. So they seem to fall into the trig integral formula, but if one of them is to the first power, if you'll think about this for a second, all this is going to be basic old u substitution, just like you've always had, because you were just lucky and it's already set up for u substitution. So whenever you see one of these kind of problems and one of the powers is to the first power, you can go directly to u substitution. And let's just kind of run through one of these to show how this would work. Now, the derivative of the sine is the cosine. Let's work this one right here. So I'm going to change this into, think of it like this, the integral of the sine of x to the 5th power times the cosine of x dx. Now I'll let u be equal to the sine of x, and I don't have to go through the whole thing of moving something over and changing it to identity. Because it's to the first power, it's already set up and ready to go. Then the derivative of u with respect to x gives me the cosine, which means that du is equal to the cosine of x dx. So now this matches up with this, and there's my u substitution right there. So I can change this entire thing into the integral of u to the 5th du. Now find that antiderivative. That would be u to the 6th divided by 6 plus c. And then the last step is just go ahead and substitute u with what it's equal to. So you'll wind up with 1/6 the sine of x to the 6th power plus c, and there's the solution. So again, just a reminder, normally, whenever you've got an integral of sine times a cosine, you'll have to run through one of these three factors. Factor something out, change it all to sine and cosine. It takes quite a bit of work. But if you're lucky, keep an eye out for, always check for that special case. If one of them happens to be the first power, then you don't have to use that rule. You can use direct substitution by using this part right here. And there's a direct substitution. You don't have to go through the long process. So there's some sample problems for you, just on how to set them up.